So, here we are looking at how to solve our systems of linear equations. In the first video we had an overview of what they were, and now we're going to look at all of our solving methods. The first one we call substitution. And I have within substitution a kind of little subset that I like to call set equal to. And that is because it is the simplest of types. We've got a system. We know it's a system because I have this little symbol here. And you notice that both equations are set to y equals something. And that is great, because if both of these equations are set y equal to something, that means that this expression on the right-hand side has to equal this second expression on the right-hand side, because they're both equal to y, so they're both equal to the same thing, so we can set these two expressions equal to the same thing, which is great. So down here you'll see that I've got one expression equal to the other expression. And now we've just got a multi-step equation with variables on the same side, and we know how to solve those. Subtract x from both sides, and then do, and we're going to get that x equals something. What you have to remember, though, is that this is only one half of the solution, because a solution is an ordered pair. So we have to find the other half of the solution. So if I have x, I just plug it into whichever formula I think, whichever equation I think is going to be the easiest for me to solve. So I plugged in 3 into this second one, because I can do 3 plus 7 for 10, which means y is equal to 10. So our solution is 3, 10. So our set equal to is kind of a very, very simple solving technique. On the second example, we've got one equation that's set equal to y, but one that isn't quite yet. But if you like this method, you could rearrange this to make it a y equals equation by adding 2x to both sides. So if we do that, we've suddenly got it y equals 2x plus 5. Well, now I can set this half to this half, and I'm going to be solving just like I did in the first example. So if you need to do a bit of rearranging to do this, you can. And then in the last example on this slide, we've got that x is equal to something. But both of them, again, are set to the same variable. So we can use our set equal to technique, because the one on the right-hand side of the equal sign will be equal to the one on the right-hand side of the second equal sign, because they're both equal to x. So I've written out what that would look like, but be wary, because you're actually going to solve for y here. You're going to get an answer for y, and then you're going to have to go back and answer for x. Don't forget ordered pairs each time for these solutions. So first one, set equal to. Really handy if you've got two equations set equal to the same variable, or a little bit of minor rearranging. Continuing on substitution. This is the example from the previous slide. What if you don't want to do any rearranging? What if you want to try a new method? This really is substitution, kind of more how I would use the word, I guess, not set equal to. You don't have to rearrange. Y is equal to x plus 3. We'll plug that information into the second equation and plug it into where you see y. You don't have to rearrange anything. Take this expression that's equal to y and plug it into where you see y in the second equation. And when I do that, I've kind of underlined that in blue, and then I've written it in blue down here so that you can see I've used that expression that was equal to y, and I've plugged it into the second equation, and it stands in for y. It plugs in, substitutes in, stands in for y. So then you're going to notice that you've got all variables on the same side of the equation. So that's going to be the difference to the previous slide. And then we're going to combine like terms, and then we're going to solve, and we get a value for x. And I'm not going to go back in and solve for y. That would be up to you. So you would plug this -2 into whichever equation you think would be easier. -2 plus 3 is 1. So we could just write that answer in. -2, 1. So this is substitution. If you've got one rearranged, ready to substitute in, do it. Example number 5. Sometimes when you're going to plug in an expression, it might have to come after a coefficient, and you're going to be distributing. And my word is just be careful. So here I've got that x is equal to an expression, And in the second equation, I notice, well, I could just plug in what I know x to be equal into the second equation where the x is. Notice it's going to come after the multiplier of 5. So in my next line, I have very carefully written out the first part of my second equation, subtract, and then I have my multiplier of 5, and then I write in my expression that I'm going to use. And in my following line, I've distributed carefully. And you'll notice that I had to distribute carefully because it was -5 or subtract 5 multiplying with this. So that has changed the sign on the inside. So that's why I say be careful. But again, we got all of our variables on one side, we combine, solve, 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 and we're solving for y. We've got y as -4. So I already put it into the correct half of my ordered pair so I don't make a mistake there. And then I would take that -4 and plug it into, I'd plug it into this equation to solve for x. 4 times -4, -16, -16 plus 11, -5. So I have my ordered pair. So this is substitution. If you've got an equation set equal to one variable with a coefficient of 1, it's very easy to plug that expression into the second equation. So, if this is a good technique when you have a coefficient of 1 for one of the variables. Okay? Our second type that we're going to look at is called elimination. And it is what it says, we are eliminating something. And it's a really handy technique to have as well. So here is our example number 6. And you notice I have a system. And I want you to look at the terms. I've got 2 x terms, I've got them lined up. I've got 2 y terms, and I have them lined up. I have them lined up for a reason. Because we can add equations together. Just line up the correct terms. Just like in adding, you have to line up the correct place values. Here we have to line up the correct variable terms. And when we do that, -5x plus x is -4x. And what's so convenient is 4y plus -4y disappears. There are no y terms. And that equals 20, 9 plus 11. And look what a very cute little solving problem now we've got is divide out the -4, we've got x is -5. What a quick way of solving for one of the variables, quicker than the other methods. So I have 1/2 of my answer, and then you'd go and plug in to get the y value. So if you've got 2 equations where you can line up the variable terms, and when you add them, something will disappear, it's a beautiful technique. So this is why step 1 is line up your terms, step 2 is add. You can subtract, but some people get into difficulties there. I really would stick with the adding. Example number 7 is, well, maybe they're not quite lined up ready for me. Do I have to do the lining up? Well, you might have to. Here you'll notice the x terms followed by the y term, and here we've got the y term followed by the x term. Well, to add them, we need to line them up. So the only thing we have to do is rearrange. And I rearranged the one with the asterisks so that they were lined up with the first one. So this is my second equation rearranged. And now they're lining up. And you'll notice that, excuse me, those 2 will just cancel out when we add them up. And I will have 3y equal to 12. Divide out the 3, you get y is 4. Again, be careful. We've got the y term this time. So you're going to plug y into one of these, maybe that one. Plug 4 into this and solve for x, and you'll have your second half of your equation. So elimination is a really good technique when you've got coefficients that are opposite, because it means when you add them up, they will disappear. You could make them opposite by multiplying through by -1, in case they were the same and you want to keep adding. If they were the same, you would just do subtraction. But I just warn you on subtraction, because if you're subtracting negatives, that can give some difficulties. But a great technique when you've got coefficients that are opposite, or you could make them opposite. But what if you don't? Here's example 8. So this time I've got my terms lined up, but my 2x and my -x aren't going to disappear when I add them. Neither is my y and my 3y going to disappear. So what could I make, how could I do this to make it elimination, which is a technique I seem to like? I could multiply the second equation through by 2. Every term multiplied by 2, because remember what you do to one, you have to do everything else. And you'll notice here, so my asterisk equation has now been turned into this asterisk equation. Everything was multiplied by 2. Everything. And now you'll notice that I'm at the fortunate stage of adding. My x terms will disappear. And I'm left with y plus 6y added with 3 plus negative 24. Solve, solve, solve. 7y is negative 21, y is negative 3. Plug it in, whoops, ready, and I'll just solve for x. So you've lined up your variable terms, but you notice if you do some adding, nothing's going to disappear. So maybe try and multiply through by a number to make it disappear. No opposite coefficients? Maybe there aren't any. No worries, we make some. So that's what we just did. Here, on the last example that we've got, example number 9, we've got first equation and a second equation, and there's no number that I could multiply either with the top or with the bottom to make it have an opposite coefficient with the other one. Sometimes you've got to multiply by 2 different numbers on the 2 different equations. And look what I decided to do. On the first one, I'm multiplying by 3, and on the second one, I'm multiplying by 2, all the way through. And if I do that, my x terms are going to have opposite coefficients. One's going to have 6, one's going to have negative 6. So you can multiply both equations, do whatever you need to do so that when you add them, one of the terms will disappear. And so when we do that, that will disappear. Add them, solve, we're halfway there, and then you plug in to get the other answer. So elimination is a really nice technique, because really you can do anything you want. Multiply by any number you want, both equations, one equation, and you'll always be able to eliminate something. So it's a very handy method. So this is a really good method when the others don't work. For substitution, you really have to have one of the terms with a coefficient of 1. Well, what if you don't have that? I don't have that here. So I couldn't have used substitution here. So elimination would have been my only technique. So elimination is a good technique to learn. So let's just look at all of the ones we've done. Here, 2 equations set equal to the same variable. Excellent. This is what I call set equal to. So we set both sides equal to each other. Substitution, when one expression can be plugged into the other. I have this expression here just waiting to be plugged into this one. So I've shown using the colour how I've plugged it in, and then you would solve. Elimination is when we line everything up, and when we can add 2 equations together and get rid of something, we do it. Here, nicely lined up, ready to go, add them up, shown it here, and then you're off and running with your solving. Make the coefficients opposite if you have to, by using multiplying both, 1, whatever you need to do, so that when you add them up, here, something will disappear. And these are just the examples I used on the previous slides. So that is how we solve systems. You've got quite a few techniques at your disposal, and on the next video we'll look at some solutions that might look a little strange and what does it mean, and then some of the applications that we're going to use all this for. Okay?